Hello again, Algebra 2. We are going into section 2.2, all about quadratic functions. There are going to be 2 videos for this section since we're going to be covering it over 2 days, and I don't want it to be too long. So we're going to start off with the first part, which is looking at standard form, and then we will look at vertex form in this video, okay? So standard form for a quadratic is probably what you recognize when you have to use the quadratic formula. That's where you get your a, b, and your c from. So ax squared plus bx plus c. To find your axis of symmetry, well, actually, let's look at what a quadratic looks like. So let's do a couple little axes here. So if I have my a value being positive, we say your graph is a smile, and it would look something like this. If a is negative, then your graph is going to look something like that. So if a is negative, it's a frown. If a is positive, it's a smile. So notice that on this graph we have a vertex, and there is symmetry to the graph. We call this the axis of symmetry, and the vertex always lies on the axis of symmetry. So to find that axis of symmetry, you are going to take the opposite of whatever the b value is. So if it's negative, then that will be a positive number, divided by 2 times a, the coefficient. All right, so that's actually a line, that axis of symmetry. So you have to say x equals, because it's not a point, it's an actual line. So I usually abbreviate this. So this is your axis of symmetry, which I usually abbreviate AOS. All right, then we want to find the vertex. Well, the nice thing is if you have found the axis of symmetry, this will immediately dump into the x coordinate for your vertex, because it's going to lie on the axis of symmetry. It's right here. And then to find the corresponding y value, you just plug it back into the equation, that x value, to find out what the corresponding y value is. So opposite of b over 2a. And from there, we want to know, what is our y-intercept? Well, remember, the y-intercept is when you let x equal 0. So if I let x equal 0, this is going to be the easiest thing to find on your graph. It's going to be whatever that c value is. This will be your y-intercept. So right here, this will be the coordinate at c. This will be the coordinate at c. And then the direction of opening, that's like what we were talking before. If a is positive, it's a smile. And if a is negative, it's a frown. And it's always good to know what your orientation is before you start trying to do your graph. Okay, so let's do a couple problems here. So we're going to graph each function, and we want to label the vertex, axis of symmetry, find 5 points. So in general, what you're going to find is I will be asking you for this: the axis of symmetry, the vertex. You want to give me the y-intercept, and we also want to talk about the domain and the range of the graph as we start to move forward. All right, so let's first start off with finding our axis of symmetry. So we're going to do the opposite of b, which means that is going to be a positive 6 over 2 times 3. So that's 6 over 6, which is 1. So our axis of symmetry is x equals 1. So on the graph, we actually draw sort of this dotted line. That means my parabola will be symmetric about that line. The vertex, now we know the x coordinate will be 1. We have to find out what the y value is. So we go back to our quadratic and we plug in 1. So that's going to give me 3 times 1 minus 6 times 1 plus 1. So negative 3 plus 1 is going to give me a negative 2. So at 1, negative 2, this is negative 2, this is 1, that's going to be my vertex. My y-intercept, like I said before, it's the easiest thing to read. It's just the c value. So I will be crossing the axis at 1 here. And using the symmetry of the graph, it means on the other side, since I'm 1 away from my axis of symmetry, on the other side I'll also cross at 1. And that allows me now to just kind of sketch my graph. For the most part, show me at least the 3 points. So you have your vertex, you have your y-intercept, and you have the symmetric point from the y-intercept. So that would give me my graph. When we look at that, the domain, which represents, remember, the x values, is going to be all real numbers. So you can just do the double branched R. My range is always going to depend on where my vertex is. So in this case, notice it's going to be y is greater than or equal to whatever that y value is, which will be -2, because all my graph is above -2. Okay, so let's do another one over here. So same thing again, we're going to do axis of symmetry. We're going to find the vertex, the y-intercept, the domain, and the range of the graph. Okay, so as we go through this, my axis of symmetry again is the opposite of b, which will be a -4 over 2 times a -1/2. So on the bottom here, so first of all, negative over negative, everything's going to be positive. 2 times a half is basically 1, so my axis of symmetry will be x equals 4. So I'm going to come out here 1, 2, 3, 4, and I'm going to draw my dotted line, my axis of symmetry. So my vertex, that 4 is going to stay there, and I need to figure out what the y value is. So -1/2 times 4 squared plus 4 times 4 minus 5. So half of 16 is 8, so I have a -8 plus 16, which is 8. 8 minus 5 is 3. So my vertex is going to be at 4, 3. So that's going to be my vertex. Notice it's now above the x-axis because this graph is going to be, I should have done that to begin with, sorry. This one's going to be a smile. We knew the other one was going, sorry. First one is a smile, this one is going to be a frown because our a value is negative. All right, so we have our axis of symmetry is 4, the vertex 4, 3. We got the 3 by plugging the 4 into the original equation. My y-intercept, you just look at your c value, is going to be a -5. So 1, 2, 3, 4. Way down here is where I'm going to cross. And I'm going to use the symmetry of my graph. So I am 1, 2, 3, 4 away. So 1, 2, 3, 4 away on this side. I know I'll also cross at that point, which allows me now to kind of sketch my graph. By getting those points, it does give you the correct width of your graph. Also, try and make sure that you have a bit of a rounded graph. You don't want to do an absolute value graph. So now we want to do our domain and our range. The domain, again, for all of these is always going to be real numbers because it keeps going in the x direction. But now look at my range. My highest value is at y equals 3 and everything is going down. So this will be y is less than or equal to whatever that 3 is. There's always going to be a relationship between your range and the vertex. It's always going to be based on that. Okay? Okay, so now we're going to look at minimum and maximum values, which is kind of related to your domain and your range. These are going to come in handy when we're looking at the word problems and trying to find the maximum height that a ball might be thrown at, or if something is going down, what is the minimum value that it's going down at, and the intervals where things are increasing or decreasing. So notice, and there's going to be a lot of repetition here. So a greater than 0, we know that's going to be a smile. A less than 0, I've already kind of drawn in here the fact that we have a parabola with a frown. So notice that if a is greater than 0, that is going to result in my having a minimum value down here. That's the lowest value. It's like the bottom of the hole that you dig in the sand. And if A is less than 0, since my graph is upside down, that's going to give me a maximum value. It's like the top part of the hill or the highest that the ball is thrown. All right, so minimum and maximum value is actually where the y value occurs. So it's going to be the f of opposite of b over 2a. Remember, that's how we found, in the previous page, we found the vertex by doing the opposite of b over 2a, and then you plug that value in to find the corresponding y. Okay, sorry for that. So hopefully this is just going to continue on. So we were looking at our vertex. So if it is going, if your graph is going up, you have a minimum value, and you find that minimum value by just finding the y value of your vertex. Same thing, no difference here. It's just a matter of whether the value is a max or a min. So minimum value versus maximum value is really what this should say. So this one will give you the minimum, and going down will give you the maximum value. The domain is always going to be all real numbers. Your range is going to depend. So if it is a minimum value, you're going to be greater than or equal to the minimum value. If you are a frown, then your y's are going to be less than or equal whatever the maximum value is. It's always the y value that gives it to you. The x value tells you when it happens, but it's the actual y value that tells you what that min or max is. So the other thing we want to look at is the intervals where the graph is increasing or decreasing. So remember, we always read a graph from left to right. So up here, as I'm reading this graph from left to right, in this region, I am decreasing. And then after that point, let me use a different color here, I am increasing. And again, you don't want to start at the vertex and go in both directions, because that would look like you're always increasing. It's from the very leftmost point to the rightmost point, the same way that we read a book. So here, notice that I'm now increasing first, and then after that point, after the vertex, I'm now decreasing. Okay, so let's kind of look at how we put this together on a graph and see how this works. So we want to find the minimum and maximum values, and even though it doesn't ask you to sketch it, I do find it helpful to kind of give myself a little sketch to see what's going on. So the first thing I'm going to notice in this first example is my A is positive. So A being positive means I'm going to have a smile, which means I'm going to have a minimum value. That's what I'm looking for, because A is positive. All right, so first thing we have to do is do the opposite of b over 2a. So that gives me a positive 2 over 2 times a half. So that's going to be 2. Again, that's when. So in 2 seconds, you reach your minimum value. But what is that minimum value? We have to plug that 2 in. So we have half of 2 squared minus 2 times 2 minus 1. So 2 minus 4 is negative 2 minus 1, negative 3. So the minimum value is actually at y equals negative 3. If I were to do a quick sketch of that graph, we know our vertex is at 2, negative 3. So the graph is going to look, we crossed at negative 1. That's just giving a quick sketch of the graph. So then if I wanted to try and figure out the domain and the range, so let's go ahead. They wanted all this information. So we're going to have a minimum value at y equals negative 3. Our domain is going to be all real numbers. The range is going to be, again, based on your minimum value, so greater than or equal to a negative 3. And now the intervals where you are decreasing or increasing, that is going to be based on the x-coordinate of your vertex. because here I am decreasing up to my vertex and then I am increasing. So it's all based on x equaling 2. So I am decreasing for all the x's that are less than 2, and I'm increasing for all the values after that. Okay? So in class, I'm going to have you do this next one on your own, but I will walk you through it here. So if you want to pause this video and try this one on your own, and then you can see if your answers agree. So here we have A is negative, which means this graph is going to be a frown, which means you're going to have a maximum value. So we go through and we want to find that maximum value. So opposite of B over 2A is going to give me a -5 over 2 times -1. So that's going to be a +5/2. Now you could also use 2.5, either one, because you're going to have to plug that in. So this is definitely one where you might want to use your calculator. So when I plug in 2.5, that means what I have here is a -5/2 squared is 25/4 plus 5 times 5/2 is 25/2 plus 9, and when you work that out, that gives you 15.25. That is going to be your maximum value. Okay, so we can give ourselves again a quick sketch just to kind of see what's going on here. So we know that at 2.5 and at 15.25, so this is 2.5 right here, my graph is up here, so it's going to come down like this. All right, so let's list what we know. We know now that our maximum value is at y equals 15.25. I know that my domain is going to be all reals. My range is going to be all the y values less than or equal to 15.25. And now talking about decreasing and increasing, we have to give those intervals. Again, remember, those are based on your x coordinate. So I'm increasing up to my x coordinate at 2.5, and then I am decreasing afterwards. So since I put decreasing first, it's going to be x is greater than 2.5, I'm going down, and x is less than 2.5, I'm increasing. Okay, so that is day 1 of our quadratics, and tomorrow we'll look at the intercept mode and doing the word problems.